Today's lesson is going to be on solving and graphing absolute value inequalities. So the objectives today is to be able to use some previous knowledge to solve inequalities, including absolute value ones, and also be able to graph the solutions on a number line. So we'll be dealing with some open and closed circles, pointing one direction or another. Let's first talk about steps to solving absolute value inequalities before we take a look at actually solving them. So when you're solving absolute values, the first step is to isolate the absolute value symbol. And specifically on one side of the equation. So whatever side that absolute value symbol is on, you're going to want to get it by itself. And so if you have some other terms like on the outside, you might want to add and subtract them. If there's a coefficient in front, let's say you had like 2 absolute value of 3x minus 4, something like this, then you would want to get rid of that 2 before you'd start, okay? And then that way, this would be isolated by itself. So the first step is to isolate, so get all the extra stuff on the other side. The second step is you're always going to split it up into 2 different inequalities to solve. And so whatever the absolute value is, let's say it's absolute value of, well, in this case, if we look back on our last example, we would have 3x minus 4 greater than 2. And so what the next step would look like is we want to split this up into 2 separate inequalities. One inequality is just straightforward without the absolute value symbol, so just reading it as 3x minus 4 greater than 2 and solving that. And then the other one, you're going to keep the inside, but what we do to solve the other one is we flip the sign, so if it was a greater than, now it's going to be a less than sign, and you do the opposite the other side. So if it was a positive 2, we're going to say less than negative 2. So again, the equation is always the same without the absolute value symbol. That's what you want to solve. But the other thing you do is just change those last 2 parts. Change the inequality sign and then make it opposite of what the other side was. And then really the third step, solve each individually. And so both cases you're going to be solving using the same process. So we'd add 4 and it looks like divide by 3 in these cases. And then the final and fourth step, graph solutions on a number line. And today's graphs, if you're going to graph them on a number line, they're either going to look a couple things. They could be a combination of open and closed circles. So you could have 2 open circles, you could have 2 closed circles, whatever that might be. And sometimes they might be both pointed in opposite directions, or sometimes they might be pointed in the same direction, which means it's an overlap. So your graphs are either going to be an overlap or they're going to be pointing opposite directions today. All right, let's take a look at the first example here. So here we're asked to solve and graph this inequality below. So here we're dealing with absolute value. So if you remember our steps from the slide before, the very first step is to isolate that absolute value symbol by itself. And so since it's right here, I got to get rid of the extra stuff that's next to it. That means I got to get rid of this negative 5 that's here. And to be able to move a negative 5, we want to add 5 to both sides. Some of you guys remembering sort of drawing a line down here when you're solving. You can do that if you want to. So what we're left with on the left side would be just that absolute value of x minus 2, and what we're left with on the right side would be 3, and we still have that inequality sign, which is less than. Now that we have the absolute value isolated, this is when we want to split it up into 2 separate inequalities. One inequality is always what you're trying to solve, the original problem, just without the absolute value symbol. And then the other one, remember, is you keep the inside, but you switch the last 2 things. And so this is going to switch to a greater than symbol, so the other direction, and it's going to be the opposite of 3, so it would be negative 3. We solve this individually, that's our third step, so if I add 2 to both sides in that first one, it looks like I get x less than 5. There's one inequality. That's one solution. And then the other one, if I add 2 to both sides, it looks like I get x greater than -1. There's the other solution. Now we're on to the step of actually graphing this. So on a number line, if I place sort of 0 in the middle, here's where -1 is, here's where 5 is. If I were to draw out the tick marks there. So right above both of those values, -1 and 5, are going to be both open circles because we're dealing with a greater than and a less than symbol. And if I interpret the first one, that's x less than 5. Well, less than 5 on a number line would be pointing to the left. And greater than -1 on the number line would be pointing to the right. So notice in this case, our graph is an overlap. So our solutions here would be x less than 5, x greater than -1, and our graph would look like this. There's our answer. All right, let's take a look at another one here. So if I follow my steps, right, the first step is to get the absolute value by itself. And notice step 1's already done for us. It's kind of nice here. So then we're already ready to split this up into 2 different equations, right, 2 different inequalities. One is the original, so 2k plus 2 greater than or equal to 2. And then the other one is you always keep the inside, flip the sign, so now it's going to read less than or equal to, and then it's the opposite the other side, so -2. Solve these like we do any others, so you'd subtract 2 first to get rid of that. It looks like I get 2k greater than or equal to 0. If I divide by 2, because there's a 2 in front of my variable, right, to get rid of it I have to divide by 2 to both sides. It looks like I'm left with k greater than or equal to 0. So there's one solution right there. If I do the same process in the next one, subtracting 2 to both sides, that gives me 2k is less than or equal to, looks like -4 on the right side. And then again, to get rid of that 2 in front, I'd want to divide 2 to both sides, and so I'm left with k is less than or equal to -2. So on a number line, if this is 0, then -2 would be down here. Both of them, notice it's equal to sign underneath, right? There's a line underneath that inequality, so both of them are going to have closed circles then above that values. And greater than 0 on a number line would be pointing to the right, and less than -2 would be pointing to the left. So notice here our graph points opposite directions. So there's my solutions, and then there's my graph. Let's take a look at one more before I have you guys try one on your own. So here we have 4, and then times, we have the absolute value of x plus 2, and then we have the -1 less than 11. So if you look back on our steps, the first step was to isolate that absolute value by itself. Well, the first thing I'm going to have to do is get rid of that -1. So to get rid of it, let's add it to both sides. So on the left side, we still have 4, and then we have the absolute value of x plus 2 inside, and then on the left side, what we're left with is 12. Now you might think that we can distribute this 4 through, but we can't. That's a big no-no, okay? In fact, only can distribute numbers if we have a parenthesis or brackets involved. With absolute value, you cannot distribute that through. So we have to keep it as just 4 times in front, okay? But to get rid of that 4 in front, since it is a multiplication, if we divide 4 to both sides, it's going to cancel on the left side and leave us with just that absolute value left, which is what we want. So if you have a number in front of an absolute value symbol, you're going to eventually have to divide that over, but you want to do that after you get rid of the other terms. Like here, we added 1 first. So on the right side, we still have, looks like 12 divided by 4, we get 3. Now that it's isolated, we're going to split that up into 2 different inequalities. One inequality is just the original problem without the absolute value symbol. And then the other inequality, right, we keep this inside, flip the inequality, and then set it equal to the opposite number, -3. We solve both of these like we do other inequalities, so get x by itself, so we'd subtract 2 to both sides. So it looks like in this first one we get x less than 1. And if I subtract 2 to both sides in the next one, I get x greater than -5. So if 0 is here on the number line, 1 is right here, -5 would be, looks like 1, 2, 3, 4, this one down here. And so since it's dealing with greater than and less than symbols, both of them are going to have open circles above those values. Less than 1 in this first one means I'd point my arrow to the left. Greater than -5 in the next one means I'd point it to the right. And so notice here they're pointing at each other. So that's when we have the overlap. So all of our solutions is going to be strictly between -5 and 1 here. All right, now it's your chance to try. I want you to pause the video and see if you can work out both of these on your own. We'll go over the answer here in a little bit. Good luck. So for the first one, notice to be able to isolate the absolute value by itself, we would have to get rid of that 2 that's in front. And so since that 2 is a multiplication process, right? If you see a 2 in front of something and you don't have a sign in between, we're assuming it's multiplying. So to get rid of it, we would have to divide 2 to both sides. So what you're left with on the left would be absolute value of ax minus 4. And then on the right side, we're left with 8 divided by 2, which is 4. Now we have the absolute value symbol isolated. This is when we split it up into 2 different inequalities. So one of them is going to be just the original without the absolute value. The other one is keep the inside, flip the sign, so now it reads less than, and opposite the other side, which is -4. If I try to solve the first one by just adding 4 to both sides, I get x greater than 8. There's one solution. If I add 4 to both sides in the other one, I get x less than 0. There's the other solution. Now if I graph this on a number line, zeros, let's put 0 actually way down here, 8's over here. You can have your tick marks in between if you wanted to. But both of them are going to have open circles above them because it's strictly less than and greater than symbols, not the equal to. And less than 0 would point to the left. Greater than 8 would point to the right, and so that's what our graph would look like here. So in the next one, to be able to get that absolute value by itself, I'd first want to move this +8 by subtracting it to both sides. So on the left, I get 3 absolute value 2x plus 1, less than or equal to what I'm left with on the right is if I subtract those two, looks like I'm left with 15. Now I still have a 3 in front that I got to get rid of, and since it's 3 times that, to get rid of it, I would divide to both sides. It cancels on the left side, and so what you're left with is just that absolute value of 2x plus 1, and then on the right side, 15 divided by 3 becomes 5. Here's where we're at the stage of splitting it up into 2 separate inequalities to solve. So the first one would be just simply 2x plus 1 less than or equal to 5, and then the other one, you keep that inside, but we flip the sign and opposite the other side. Subtract 1 to both sides to be able to solve, so it looks like I get 2x less than or equal to 4 here. And if I divide by 2, you get x less than or equal to 2. So there's one solution here. If I subtract 1 to both sides, I get 2x greater than or equal to -6. And if I divide 2 to both sides, it looks like I get x greater than or equal to -3. And so on a number line, if I were to graph this, notate where -3 is, notate where 2 is. -3 is obviously going to be below 2 on a number line. Both of them are going to be closed circles here because of the equal to underneath. And then greater than 3 points, -3 points to the right, less than 2 points to the left, and notice here we have an overlap. So all solutions between -3 and 2, and also including those values, will work for this inequality. So this concludes our lesson on solving and graphing absolute value inequalities. So you can check out the practice with the key, try some problems if you want, but otherwise get to that homework quiz that's due before midnight. Have a great rest of your day.